Hi, my name is João Leite, and I'm going to talk about our paper Toxic Language Detection in Social Media for Brazilian Portuguese, New Dataset and Multilingual Analysis. Before we start, I'd like to thank my colleagues Diego Silva, Carolina Scarton, Kalina Monteva, and our universities, the Federal University of São Carlos, the University of Sheffield, and also thank SO Big Data for financing both mine and Diego Silva's visit to the University of Sheffield. In the introduction part, I'm going to briefly talk about the relevance of Portuguese in social media. So for the relevance of Portuguese in social media, Portuguese is the fifth most spoken language in the world, with more than 250 million speakers in 10 countries, and Brazil on itself has more than 200 million inhabitants, which represents more than 70% of Portuguese speakers in the world. And also, Brazil is ranked 4th in unique users at Twitter as of July 2020. Other interesting facts here on the right is that Portuguese is the official language in 9 countries. It's the 5th largest online user population. It has 121 million online active users and also 687,000 native Portuguese speakers in the USA. So for the related work section, we're going to talk about the publicly available datasets for this task. The data displayed in this slide we got from hatespeechdata.com, and it displays datasets that are publicly available for this task. And we can check that although Portuguese is very relevant in social media, the number of datasets, the number of total samples available for Portuguese is very small compared to other languages. So Portuguese only has 2 datasets. It has about 7K number of samples on those 2 datasets combined, and although the ratio is of toxic example is good, it's 67%, it is quite small compared to other languages like Italian has 5K, Indonesian has 6K. So here I'm going to describe the 2 datasets that are available for Portuguese. The first work is a hierarchically labeled Portuguese hate speech dataset. This work is a relevant work for this task. It is the biggest dataset available for Portuguese. The data was collected from Twitter. It has an okay amount of abusive samples. The problem with this dataset for Brazilian Portuguese specifically is that this is an European Portuguese dataset. The second dataset available for Portuguese is displayed at offensive comments in the Brazilian web, dataset, and baseline results. So as you can see, this is a Brazilian Portuguese dataset. The problem with these datasets is that it is extremely small, with just about 1K examples. The percentage of abusive is okay, but another problem is that the data was collected from a news website. It is not from social media. So again, this is not the optimal dataset you would want for Brazilian Portuguese in social media. Their results show it because they've got 77% F1 score, but it's a weighted F1 score, so they're basically predicting the majority class. So this is the same table we've displayed before, but now with our dataset included. So now we've got one more dataset available for Portuguese, and the number of samples jumped from 13th to 8th, surpassing Italian, Spanish, German, Indonesian, and the number of positive samples. This is the only language now that has balanced classes if you take into account all the 3 datasets. We've got 50% of the samples being toxic and 50% not toxic. In the data collection section, we're going to talk about the challenges we faced during collection of the tweets and how we managed to deal with it. The problem that we came across is that toxic tweets are only a small fraction of all the tweets. So if you would collect tweets at random, you might end up with a very small percentage of toxic examples. So in order to deal with this problem, we've designed a pragmatic approach to collect data. We've designed 2 methods. The first one is a keyword-based tweet collection, where we defined a handpicked set of words that highly indicate toxicity for each of our categories, and then we've collected tweets that mention these words. This method can introduce a keyword bias into the model, but it guarantees that a dataset will have a decent amount of toxic examples. And so it composes 60% of the dataset. But in order to balance this bias factor, we've also used the influential users tweet collection, where we gathered the top 100 most influential users at Brazilian Twitter. So this method is not bound to keywords, so it can help the dataset be less prone to bias with keywords. And this composes 40% of the dataset. And another interesting thing to talk about is that we used GateCloud's Twitter collector, and we've used both of these methods to collect tweets during 15 days, and we ended up with more than 10 million unique tweets. For the data labeling part, we're going to talk about how did we find candidates to annotate our dataset and how did we select them, and then in the end we're going to present the dataset characteristics. So for selecting the annotators, we've designed an online form and we've announced it at Federal University of São Carlos Facebook group with more than 129 students from the university volunteering. In the end, we selected 42 volunteers by their demographic background, and then we divided them into 14 groups of 3 annotators. The annotation guidelines were made by us, and then we distributed it for everyone. And finally, the annotation process took up to 1 month. Some annotators didn't want to finish the task, so they needed to be replaced, and this took up most of the time that we had. This is the demographics for annotators. As you can see on the left, there's a table displaying the sex orientation, and the ethnicity. And on the right, we have a distribution of age. And as we've selected annotators from a public university, most of them are undergraduates, so they're pretty young, but our ages range from 18 years old to 37 years old. And this is the summary of the dataset. We've called it TOLD-VR, which stands for Toxic Language Dataset for Brazilian Portuguese. Its characteristics are that it is multilabel with 6 categories. It has 3 annotators per example. Annotators have diverse demographic backgrounds. It is 3 times bigger than both the available datasets combined for Portuguese, with a total of 21k examples, and it is available at this repository down below. The dataset categories that we've selected are LGBTQ plus phobia, insult, xenophobia, misogyny, obscene, and racism. And on the right, we've displayed a table that shows the distances between the categories. And the way we've calculated this table was that we selected the top 100 most frequent words for each category, and then we've calculated the Jacquard distance between these sets. And an interesting fact here is that the distance between obscene and insult ended up being way smaller than the rest, so this might indicate some correlation between them. Inter-annotator agreement with Krippendorff's alpha shows the agreement between the 3 annotators on the examples, and LGBTQ plus phobia ended up having a higher score. This might indicate some keyword relation between the class, and LGBTQ plus phobia ended up having the highest score and racism the lowest score, and in the end the mean of all classes is 0.55, which in the right here, although this is a kappa table for interpretation, you can also use it for Krippendorff's alpha, and our data set stands on moderate agreement for the mean of the classes. This is the distribution of the classes if you select the data based on the number of agreements of the annotators. So you can select the data set, the examples that have 3 agreements, 2 agreements, and that examples that at least 1 annotator marked as toxic. We prefer the later one because makes the data set more balanced, and also it becomes more generic, like you would use this data set to create a model that can raise a flag for moderators to look at, in the sense of if someone found that to be offensive, maybe that's worth to raise a flag and then make a human moderator look at the example. with our dataset constructed, we wanted to have some classification experiments. So this section, we're going to display both the binary classification experiments and the multi-label classification experiments. We're going to start with the binary classification. And for a baseline, we've designed a simple bag of words with AutoML. On the left here we have the confusion matrix, and on the right a classification report. We can see that we got a macro average of 74% F1 score, and it did pretty well on both classes. As you can see, the negative class has 0.75% F1 score and the positive class has 0.72% F1 score. Then we've tried an experiment with zero shot with OLED dataset, which is a huge English dataset on hate speech. We wanted to see if we could train a multilingual BERT with only English dataset and then predict our Brazilian Portuguese examples. And the model actually learned something, but as we can compare with our previous baseline, this model did way worse than the baseline. So this contributes to the fact that you would want language-specific datasets for this task. Then we've designed a multilingual BERT for classification using only ToadBR. We've trained with ToadBR and predicted on ToadBR, and this is the best model that we could find. It is not way better than the baseline, but it improves a bit, especially for the positive class. As you can see, recall is now 0.82 with F1 score of both classes being 0.75, and on the left here again the confusion matrix. Then we wanted to make a transfer learning experiment with OLED dataset and ToadBR. We've joined both datasets and trained a multilingual BERT. I guess you can say that this model improved a bit over the last slide, but it's not significant, and the training process became way harder because OLED dataset is so big. An interesting finding about our dataset is that it shows the importance of large datasets like ToadBR. As you can remind, the biggest dataset available for Portuguese had about 5K samples. So if you would look at our dataset and it only had 5K samples, it would stop at the learning curve very early on, where it could have learned more and increase the performance of the model. So this might indicate that this task requires somewhat bigger datasets than the ones available now. The final section of this presentation will be about multilabel classification. This is a much harder task than binary classification, basically because when the categories are not grouped into a single toxic category, each individual class becomes so imbalanced that it is hard for a model to try to learn something about each class. We've designed a baseline that involves the same approach for binary classification. We created bag of words and AutoML models for each class, but in the end the model couldn't learn anything. It basically classified every class as being non-toxic for every single example. The only classes that it learned something were insult and obscene, because they were not as imbalanced as the other classes. We also designed a more robust classification model with a BERT for multilabel classification. As you can see here, we've displayed both insult and obscene classification matrices. We didn't display the rest of the classes because they were all classified as non-toxic, so it wasn't worth showing them, but as you can see, this task is much more difficult than binary classification because of the imbalancement of the classes. So this concludes the presentation for toxic language detection in social media for Brazilian Portuguese, new dataset, and multilingual analysis. The dataset and experiments are available at this link, or you can scan this QR code and it will get you directly to the repository. Thank you.